Hello, and welcome to another episode of AI Buzz. I'm your host, Nick. Thanks so much for tuning in today. I have some awesome stories from the world of machine learning and artificial intelligence for you. Let's get to it. So, machine learning is being applied to a lot of cool areas, including research. Some really cool things happening. This story is about how scientists at the world's most cutting-edge institutions are doing fundamental particle research. So, one of the tools that scientists use for particle research is a synchrotron. And essentially, I'll give the high-level explanation of this because that's about all I know. They accelerate particles at close to the speed of light and then collide them. And in the case of a synchrotron, they do not get collided. They are simply guided around a ring with magnets. And when a particle changes direction, that's kind of considered a source of acceleration. And it's a fundamental law in physics that when a particle accelerates, it emits light. So that's exactly what these tools do. They're vastly more complicated than what I described. They typically span miles and miles in circumference because you have to get these particles sped up very close to the speed of light and essentially make them emit by curving around a corner. Not a corner, kind of a half circle type of thing. And then the light beam from the particles can be focused, and a lot of cool research is being done in very broad fields such as chemistry, biology, physics, with the resulting radiation that comes from these particles. So these light sources cost billions of dollars. At Brookhaven National Lab, I know that they have one that was over $1 billion. They take a lot of extreme measures to keep the beam as bright and focused as possible. Scientists, really battle this. They try to keep the different properties of the beam as steady as possible so that they can perform the highest quality experiments. And the light from these tools, the synchrotrons, can usually fuel numerous experiments all at the same time. And in order to keep this beam as tightly controlled as possible, they're turning to machine learning. So they developed a model that learns about the fluctuations in the light source and then tries to counteract any fluctuation to make it more stable. And as training data, the team that did this was at Lawrence Berkeley National Lab. They used, so they're using the magnets to direct electrons around bends. They had all this data of these fluctuations from previous experiments, and they used that as training data, and that the model learned how to counteract it. So they were able to get a much more focused beam out of this. So they're really excited about the far-reaching impacts that this work's going to have on some big fields, chemistry, biology, physics. Tons of different fields use the radiation from these tools. So the fact that it's going to be more stable is really exciting. Next up, machine learning changing the world. That's kind of the theme on this show. It's probably only getting started, is what a lot of experts would say. There's a lot of work being done on the software, probably not as much done on the hardware. Maybe there is, maybe we just don't hear about it as much as the software. Covering and innovating on a hardware level definitely has got to be slower. I know in the chip research that I've been involved in, essentially takes forever to do some of this research because the chips these days are so many layers thick because you're trying to go to such a small node of technology. Innovation's just slow, so it makes sense that software is going a little faster, at least for now. Machine learning is really igniting a specialized hardware market. So while the software's heating up, hardware's trying to heat up as well. Covered several stories recently on companies like Neural Magic. They're trying to run inference models on just stock CPUs that pretty much everyone has. Other companies are focused more on the training aspect of the technology. And this just inherently requires huge amounts of data and huge amounts of compute to do the job. For deep learning, there exist Tensor processing units that Google's working on, and these do the optimizations that are required for manipulating and doing operations on tensors, and essentially having many layers of these tensors and these manipulations is what the makeup of a neural network is. So combining all these different types of software and hardware together, it's really just, there's a lot of competition. And for now, actually, graphics cards are kind of the hardware of choice. So CPUs right now, they're definitely not good enough. They're not optimized enough, and they aren't built for the operations that are needed. So GPUs, they're kind of built for tensor manipulation from computing graphics. They're the hardware of choice. They're readily available and widely used. So the increasing applications demand for training large neural nets has really just fueled a fire in the GPU market. And in that market, NVIDIA has absolutely dominated. They read the next several years. This is back in I think 2010 or so. Actually, no, they came out with CUDA in 2008, I believe. So back in 2008, they predicted the next decade so well because they invested heavily into machine learning libraries such as CUDA, like I mentioned, and these enable GPUs to be used optimally for deep learning compute. So to follow that, they made a bunch of specialized GPUs. So right now, the Volta GPU are their high-end training GPUs, and they have the Turing chips for inference. The market for these GPUs are only going to continue to grow as deep learning becomes more of a staple in our lives. Services such as Amazon Web Services will even let you rent clusters of these high-end GPUs for training. There's a lot of other services too. Until tensor processing units can be effectively produced, I think we're going to see a huge demand for NVIDIA GPUs in the future. So we're stuck in this GPU territory where CPUs they definitely don't cut it, and tensor processing units are not ready for mass implementation yet. So for now, we're stuck with GPUs, and NVIDIA essentially has a monopoly on that market. So kudos to NVIDIA for being an early adopter and being able to predict the boom of deep learning. Next up, this story hits home with me. I'm a coffee fiend. I drink it pretty much constantly throughout the day. So this story definitely caught my attention. I heard that Starbucks is using machine learning to improve their platform. So they're essentially going to be using AI to assist in recommending products to consumers on their mobile and online platforms. Cleverly named Deep Brew, very, very cool name. The model studies customer behavior over time to determine what products they might be most interested in purchasing, considering factors such as weather, ingredients, and location. A very cool set of factors, and I'm sure there's much more. I think there's a list of 12 that they stated in the article that I read earlier. Very cool. So putting weather in as a factor, that's just awesome. If it gets extra cold, they'll recommend a hot beverage, most likely. I don't know how the model turned out, but that'd be my guess. And what they did is they collaborated with Microsoft Azure. And So the post I read was by Microsoft, and they essentially they used this implementation of their platform to help out Starbucks and their recommendation engine. They also talked about how Azure's a really good platform for spinning up and creating insights quickly. So they're definitely in a war with Amazon for the cloud compute, cloud machine learning aspect of artificial intelligence. So I saw the story. I thought this is great that they have a platform that can create this type of granularity and insight into customer behavior. But how well does it work? That's when you're implementing something like this as a company. As much as the technology is awesome, all it really comes down to is the bottom line. And crazy enough, well, not crazy enough, it's not surprising, I should say, that Starbucks' performance is booming. Sales are up 6% the Q3 earnings call. And according to an article I read on MarketWatch, they say there's over 17 million rewards members that are now signed up, and they are going to keep fueling all this data that Deep Brew is processing for its recommendations. And some of the analysts that are taking a look at this company are saying that this new stream of data from the rewards members is going to help even further with staffing projections. So having all this data on your customers is really going to help determine how many people you need on staff, what time, all of that. They think it's going to lead to better efficiency and customer satisfaction as well. So this digital push by Starbucks is really going to keep fueling sales, most likely. It's going to get a finer degree of personalization and targeted marketing. And yeah, they have an awesome name for this too, called Deep Brew. So next up, agriculture fuels the world, and we often take advantage and we take for granted the abundance of food in the United States. Farming is very, very hard and requires some serious skill to make crop yields where they should be. Unfortunately, there are a lot of pests that can attack entire crops, and this is independent of how skilled the farmer is. So genetic engineering is one of the methods that have been growing in recent years to combat these problems. However, people are wary of these techniques for health reasons, which there's definitely some credence to that. They cite the fact that our bodies are really not meant to be dealing with these genetically altered versions of some of these crops, such as corn, for example. People do not want GMOs, which I think there is definitely a lot of truth to that. So instead of going that route, artificial intelligence is being used in several ways in the agriculture industry. Computer vision is perhaps the most well-known example of how farmers can be assisted by drones to tend to their crops and seeing when something is going wrong. And this results in very quick responses to anything that's going badly, and hopefully resulting in them saving crops. A couple companies that are leaders in this area, Root AI, it's taking a unique approach of applying AI to this field. One of their products is named Virgo, and it's an autonomous fruit picker. So that essentially drives around and can see when tomatoes are ripe and pick them at exactly the right moment. Another company, which is really cool, I love reading about this one, it's called 80 Acres Farms. They're trying to remove essentially any uncertainty from the growing process. So they're trying to make farming literally a science. So they're using AI to watch crops every step of the way. They have indoor farming facilities that are going to be watching the leaves of their crops and seeing if they're getting the proper nutrition. And then they have LED lights that are all hooked into this system that will be able to control the photosynthesis process. and they state that this approach to farming is definitely the best shot at yielding extreme crop growth. And these are two very innovative companies that I think we'll begin to see more of in the coming years, applying AI to farming. That's about all for this episode of AI Buzz. Thank you so much for joining me today. My name is Nick. I'll be back with you very, very soon in the world of artificial intelligence and machine learning. I'll have cool stories for you coming up. Thanks for tuning in once again. Bye.